Okay, so hello everyone. I'm very excited to be here today at DSC MENA, and it's a great opportunity to meet you all. First of all, I'm Ahmed Abulkhair. I'm a senior data scientist at ALX Africa. I have about 5 years of experience in data science. I worked in multiple companies and in multiple spectrums of data science. I worked in forecasting, prediction, and now I'm developing LLM-based applications for ALX. Those applications aim just to make the educational process more scalable and more affordable for the youth of of Africa. And I'm here today to share my insights about harnessing large language models and advanced analytics. So imagine reading books for 76 years, non-stop, 24/7. This amount of data is approximately the amount of data in which a model like GPT-2 was trained on. It was a gigantic model of 1.5 billion parameter. And at this time, it was incredible. But for some reason, GPT-2 was not of the best performance. And the OpenAI team just decided that there is some potential in the idea of scaling up those models. So they went for a larger one, really larger one, up to 175 billion parameters. The amount of data in which a model like GPT-3 was trained on is approximately equal to 3,000 years of continuous reading to books and textual information. And I remember that day when I heard about GPT-3 and started reading the paper, and I realized that such model is almost trained on every page on the internet, every website, every blog post, every tutorial. So I wrote an article named "The Model Simply Knows," because for me, a model like GPT-3 was trained on the entire human civilization. Our civilization has knowledge in the internet. We have books, websites, blogs, tutorials. So a model like GPT-3 was mind-blowing at that time. And I think this big innovation never comes out of the blue. So if you can remember, before 2017, all of our natural language modeling tasks were stuck in one main problem called the vanishing gradient problem. We cannot go for longer sequences of text because our recurrent models will lose signal about words when we go further, when we go longer in text. Until a famous paper called "Attention is All You Need" just came out in 2017. Attention is all you need just solved two problems in the language modeling that we faced before. First problem, it allowed us to do some parallel processing for text, for words, so we don't need to wait until a huge passage of text to be consumed by the model. And the second one, which is more important, it was a mathematical derivation that can give importance to relevant words in the text. So we have now a model that can know which words are most important, and we can do parallel processing. And based on the idea of attention is all you need, the team of OpenAI just developed their first GPT-1 model. This model was trained to predict the next word in a generative manner, and it was not of the best performance at the time. But in 2018, Google team just developed BERT model. BERT model was using the attention mechanism excessively. The difference between GPT and BERT model is that GPT was using attention mechanism from one direction, but BERT was using attention from both directions. That's like language in Arabic will start from right to left for GPT, and that's only. But for BERT model, language in Arabic will be from both sides, from right to left and from left to right. And it was trained on masked language modeling. And BERT was so good at that time. And most of our NLP applications was basically reliant on the BERT model. We got tons of derivations, tons of fine-tuned BERT models. We got some things like Roberta model, BERT topic, etc., etc. A lot of Hugging Face stuff, a lot of fine-tuned models from the period of 2018 until reaching GPT-3, the gigantic model I just thought about a minute ago. And I think from the moment we just start typing some text to GPT-3, we realized that those models got some different capabilities, some bigger perspective, powerful potential. From that time, the data science community began to think about some things that got changed forever. For example, we are no longer thinking of the labeling of our data. Now we can just use a few short learning prompts with some LLM and got our data labeled, and began to think of why just reading dashboards and figures, numbers here and there, why not having a summary for our dashboard, a natural language summary. Also, in field like explainable AI, and instead of having some plots in maybe chab values or line plots, we are now providing a natural language explanation about why the model gave such a prediction to those values. And what was so interesting about LLMs is that they are understanding a unified and simplified language. It's the prompt, and we all just speak it and use it in our daily life because it's natural text at the end of the day. And despite the easiness of the prompt, it was able to just trigger the full potential of our LLM model. So an area of research called prompt engineering started exploring various ways and combining some art and knowledge when just emptying data to LLMs to craft the best possible performance. A lot of prompting techniques just came out, like chain of thoughts. Chain of thoughts is the basic foundation of the reasoning models we have today. You can just tell your model to follow a sequence of rational steps when solving a problem. And that's why reasoning models got some thinking and thoughts internally, because they want to fulfill the criteria of driving rational steps. Another prompting technique like react. React means reasoning action. So the model is now will be capable of reasoning about some task, reasoning about some input, and do some action based on that reasoning. Another prompting technique like step-back prompting. Step-back prompting is just about asking the model to double-check the final answer before giving it to the user. And prompted chaining. Prompted chaining is about dividing a bigger task into smaller ones. Each one is concise and just focusing on achieving some specific thing. And they went further to some things like prompt optimization. So they began to think of prompts as an optimization problem. I have a prompt that causes some errors in the output. What if I can just do some optimization to this prompt based on those outputs in order not to get those wrong examples again? Prompt ensembling. In this technique, we are just using 3 or different prompts. They have few differences between each other, and we got the collective answer of those prompts as a result of some maybe logical problem or so. And some more interesting prompting technique is called meta prompts. Meta prompts is the study of prompts that can create another prompts for our applications, for our apps, and so on. So I think from the moment we realized that there is a huge potential in LLMs, and we started talking to them in the right way using prompt engineering, we start to think about what if we can integrate LLMs in our apps? What if we were able to just make those things able to interact with the environment? And what I mean by the environment here is everything that can be put into an app. What if I used LLMs to read data in the database and run queries? What if I used LLMs to read some financial data and give me some financial positioning report? What if I used them to read a course content and give me grades or an exam for this course? What if I used them in data engineering to read logs and fix failures? So we entered an era that is called Agentic development era. In this era, we are trying to build agents, and agents are apps with LLMs used as a brain. One famous example of agents is text-to-SQL. So the industry always had a dream of what if we are capable of querying the database using natural language. And I was involved in building one of those text-to-SQL agents 5 years ago in 2019, and it was terrible. Its accuracy was about maybe 50 to 60%, because SQL is difficult for any large language, for any model to understand. So with LLMs, we know that LLMs know how to write SQL, because in the training data we got thousands of SQL tutorials, of SQL courses, white papers, etc. So what if I used that clever SQL developer according to my business process, according to my database schema, according to my tables and rows and columns? So a very good example is about data, about text-to-SQL agents is something called Query GPT. Query GPT is developed by Uber, and this text-to-SQL agent just managed to save them about 140 hours per month that were spent in querying databases, and let the data analysts now focus on more strategic thinking. LinkedIn also have a massive text-to-SQL agent, and they managed to get accuracy of 95% accuracy of that agent. Another very important and common application of agents is retrieval augmented generation, RAG. So imagine a company that have tens of pages of files. Those files can be in Word file, Excel file, etc. And we can just read what's inside those files and got a final answer to the user that has been written in a natural language that is understandable. So some companies like JP Morgan used LLMs and RAGs to read the financial reports. They are very complex reports, and produce something like financial positioning report at the end. And this is a very famous application of RAG. We have types of RAGs, like the basic RAG I just explained, and the iterative one. This RAG is trying to just refine the answers with time. And corrective RAG is trying to validate the final answer that the LLM just formulated in a way or another with the knowledge base, our data again. And the graph-based RAG, and this one is interesting because it uses the graph capability. Imagine we are dealing with a course material where listen 2 is connected to listen 1 and listen 3 in something like a graph. So we can use LLMs to read our data in a graph format, so it will be more aware about the connectedness between elements. So because of the complex applications we use agents in, there is a terminology right now called agent ops. Agent ops is very similar to DevOps. It's very similar to ML ops. And it focuses on some basic development stages. In the development stage, we need to have tools and packages that can write code with our LLMs faster. We have some things like LangGraph and LangChain, small agents also. Also, when creating an agent, we have a lot to version right now. We need to do versioning for our code, our data set, if we got any knowledge base, our prompt, because even the tiniest change in the prompt will change the output, and our LLM model, if we have a fine-tuned one or a local one, or a local model. And tools like LangFuse and LangFuse are doing this perfectly. Also, we are now thinking about multi-agent orchestration. They began to think about how to make two agents speak to each other, how to facilitate the communication between one agent and another tool. You may have heard of concepts like model context protocol lately. And recently I have heard about something called agent-to-agent communication. It's developed by Google. So they are now thinking about how to make these team members communicate effectively with each other to achieve a unified goal at the end. What are the problems that we need to overcome to build better models? We have a huge problem in the evaluation, because LLMs can be adapted in various tasks. They can output various types of data. So evaluating such diversity is hard. And our normal, maybe evaluation metrics like BELOW for translation or Rouge are just not enough. They don't measure the creativity of the model. We have also a problem of scalability. Those models are gigantic, so we need to make them smaller. Some techniques were developed like quantization and allowed us to use LLMs now on our laptops. So they began to think about the parameters. Those parameters were normally put into 32-bit precision, and they tried to compact this into 8-bit precision. So we got smaller models that can run on our laptops. Also, we have another technique called distillation. Distillation means that we build a smaller model. This model will act as a student that will learn from a teacher model, a bigger one. A very famous example is GPT-4o and GPT-4o mini. And you can realize the difference in cost. For GPT-4o, you will spend about $15 for 1 million output tokens, but for GPT-4o mini, you will spend about 0.6 for 1 million output tokens. So I want to conclude of that opinion about LLMs because I really love them. And I think that LLMs will become the next calculator. You can't use a calculator if you don't know the basic arithmetics. But at some point, with the harder problems, picking up a calculator is inevitable. So we will come to a point when we need to just adapt LLMs to maybe every app. That's all, and thank you so much. Is there any question?
Accuracy, you said 50% accuracy?
Yes.
How do you measure accuracy?
In SQL?
I'm a non-expert in general accuracy. How do you know that these models are giving a good output?
Okay, so evaluating text to SQL agents is normally tough. And even defining what accuracy is not a very easy thing to do. Maybe for SQL, if you just interacted with the application maybe 10 times and you got maybe 7 out of 10 right queries, right answers, you will just say that I got 70% accuracy. But this is not fully accurate because accuracy is, I think, very tough to define for various applications. So defining accuracy is not that easy. By the way, this is a major problem in all of the data science applications and data science use cases. Evaluation is really tough, especially when you have something that will not maybe have a fixed output over time. Output will be diverse, output will be changing over time, so evaluation is very tough. But overall, you can just put your application into test. If it got the right answer 7 times out of 10, it's 70% accuracy. This is maybe a simplification of what the accuracy did in those applications.
How do companies compare the accuracies between the models and like define their accuracy? You have said that there's a major problem that the model produces different outputs for the same question, and that they cannot define the accuracy. So how does like DeepSeek say it's better than ChatGPT or something?
Okay, I will tell you what is normally being done in the academia, and I will tell you what is maybe the real situation. In the academia, we have some fixed benchmarks. Those benchmarks, maybe it will be a data set of coding problem. Whatever model just solves 8 problems out of 10, this is 80% accuracy in that benchmark. We have another data set of translation. We have maybe Arabic phrases and English phrases, and whatever model managed to get the desired accuracy for maybe 90% of the time, this is 90% accuracy in that metric. These are metrics developed by the academia, the research field, but in practice, we just use them. I think no company has the ability to dedicate a full team that will spend some time researching how to evaluate in a more accurate way. So that's it. And by the way, evaluating, especially LLMs, is very, very tough problem. They got diversified outputs, they got diversified tasks to be evaluated on. And whenever you heard like DeepSeek is better than OpenAI, this will be against the metrics that were developed by academia in various tasks, not in general or overall. Any other question? Shukran.